Welcome to our next lesson in triangles. We'll work out some problems in triangles. So ABC is a triangle in which BE and CF are two equal altitudes. So altitude means it's perpendicular. So what is given here? Equal altitude. So when they say altitude, angle F is equal to angle E is equal to 90 degree. Its altitude. Equal means CF is equal to PE. If we are able to draw the diagram and perfectly understand the meaning of equal altitude, the problem is over. Now he says using RHH congruence rule prove that the triangle. He has given the rule also. So we have to use the RHS congruence rule. So we'll consider triangle CFB and BEC, these two triangles. So it's what is given. So here CF is equal to P, one part is there. Another angle F is equal to angle E. So and BC is common to both the triangles. Therefore, by RH has congruence rule, what is the RH congruence rule? BC is the hypotenuse for these two triangles CFB and CEB, and one angle is 90 degrees. The other side also is equal. CF is equal to B, two sides and or hypotenuse side. Both we know or means it's perpendicular 90 degrees. That is also conditioned. So by RH congruence rule, triangle CFB and BEC are congruent. So what is the meaning? So now angle B is equal to angle C. Therefore, angle B is equal to angle C. So we have proved these two angles. Therefore, ABC is an isosceles triangle. Actually, AB is equal to AC. Therefore, ABC is an isosceles triangle. And also, AB is equal to AC. So we'll move to next problem. L and M are parallel lines. So let us L and M parallel line intersected by another pair of parallel lines PQ. So let us say some line. This line is called L. This line is called. So another parallel line. As shown in the figure, two parallel intersect each other. To prove that the triangle. So as shown in the figure. So to prove the triangle ABC is congruent to triangle CDA. So we have to prove these two triangles ABC and CDA are congruent. So see the mark. So L is parallel to M. So this is alternative angle. So similar way P is parallel to Q. So this is also an alternative angle. So when two angles are equal, the third angle also should be equal. We can mark this third angle also. All the angles are equal. And AC is common. What else you require one? So AC is common to both triangles. So angle CAB is equal to angle ACD, and angle ACB is equal to angle CAD. Therefore, by ASA congruence rule, triangle ABC is congruent to, when you start with AB, here you have to start with CD, triangle CDA. So if you observe, CD is equal to AB, BC is equal to DA, and angle B is the center is equal to angle D. So it will, when two triangles are congruent, it will come in the same position. So we can check whether the order is correct this way. So we'll move to next problem. Line L is the bisector of an angle A. So this is some angle A. So we have drawn a bisector. So we take some point B, any point on the line L. Draw two perpendicular lines from P. 1, 2, meets the two lines at P and Q as shown in the diagram. So to show that triangle APB and AQB are congruent. So how we prove? So AB is common to both the triangles, and angle PAB is equal to angle BAQ because given its bisector. So BP is perpendicular. So angle P is equal to angle Q is equal to 90 degrees. So what about this angle? The third angle also should be equal, perpendicular, and this bisector angle, these two angles are equal. The third angle also equal. Therefore, when AB is common, so by ASA congruence rule. Why this ASA congruence rule is applied? Side is common, so angle A is bisected. Actually, angle this B also is bisected, is equal. Why? What about this? What about this PBQ? PBA is equal to, it's 180 minus angle P or 90 degree minus half of A. Similarly, angle QBA is equal to 180 minus angle Q also is 90 degree minus half of A, same. So these two angles are equal. So by ASA congruent, when these two triangles are congruent, so what else you can observe this? by ASA congruent. So triangle APB is congruent to triangle AQB. So what we know, AB. So AB is common. Here also AB. Same way should come. AB is common, and also what about now? Actually PB is equal to QB, and also AQ is equal to AB. We can now observe in this problem, the same order is maintained. So we'll move to next problem. So now diagram is given. So the student, it will be better if the students try to draw the diagram themselves whenever they see the problem. Then they will get the clues how to proceed with the problem. So in this it is given in the given diagram AC, what it says, is equal to AE. It's marked AC equal to AE, and AB is equal to AD. See, it's marked. So these two are marked here. Angle BAD is equal to angle EAC. Show that BC is equal to DE. So how we can go about this? The diagram given. What is it? BC is equal to DE. You have to prove. So we'll take these two triangles. So what two triangles we have to take? So we'll consider triangle BAC and triangle ADE. So in this AC is equal to AE. It's given. So we will write as DAE. That order will be, so it's coming, say AC is equal to AE. Is given. What about AB is equal to? This also is coming in the same order, no? AB or BA. BA is equal to DA is coming in the same order. It's given. And the angle BAD. So the angle BAC. So what about angle BAC? Angle BAC is equal to angle BAD plus DAC. So what about angle DAE is equal to DAE is equal to angle EAC plus angle CAD. So these two are same, angle DAC or CAD. What about BAD? Angle BAD is equal to AC. It's given. Therefore, by 1 and 2, angle BAC is equal to DAE. So what about now this triangle? Angle BAC, same order, no, is equal to angle DAE, this angle. Included angle of the triangle. Therefore, the two triangles are congruent. So we move to the next problem. AB is a line segment, some line you can say, and P is its midpoint. He says midpoint means, so the first clue is given is AP is equal to PB, its midpoint, on the same side of AB, such that angle DBAD is equal to angle ABE. So these two angles are marked. These two angles BAD is equal to angle ABE, and angle EPA. So these two are marked. EPA is equal to angle DPB. Show that the triangle DAP and EPB are congruent. So AP is equal to what? Two triangles. Triangle DAP is congruent to triangle EBP. We have to prove. So this way, see, this AP is equal to BP, number 1. So this is given. Next, angle BAD. Angle A is equal to angle B. So this is angle A is equal to angle B. To be very precise, same thing, This is given. So what is one more factor? What about this angle? So EPEA is equal to DPP given. Now you add angle DEP to both. If you add these two, what you get? Angle APD is equal to angle BPE. This is what we require for this is to triangle. Angle BPE is equal to angle APD. So 1 by 1. AP is the equal line. So by 2 and 3. By 1, 2 and 3. So what is the rule we apply here? Angle side angle. By ASA, congruence rule, triangle DAP is congruent to triangle EBP. What is the one side column equal? AP. What is the angle? Angle A and angle this one. So we have to add now. From here, this angle is equal from here to this angle over. So we'll move to next problem. So with this we have come to the end of this this chapter. Thank you. In this chapter now you would have observed two difficult one. You have to draw the diagrams again to understand the basics. What is given. So you try to correlate with the congruence rule, either ASA congruence rule or RHS congruence rule. We have to find exactly the order in which the triangle congruent, and then we can check with the direction when whether length or angle should come in the same place as you give the answer. For example, in the first problem, so when angle F and E are perpendicular, so we have shown. So this angle F should come in the middle means here E should be in the middle. The same order should come. Thank you for listening to this. Please repeat the problems to understand the basics.